temperature, 20 Newton force is applied. Okay, as we were discussing yesterday, when the blocks are in contact with each other, all of the bodies or all of the blocks will move with same acceleration. 6 kg, 3 kg, 1 kg will move with same acceleration because they are in contact with each other. If they move with different accelerations, they might not be in contact. But as they are in contact, they should move with same acceleration. And how much is that acceleration? Acceleration, force equal to mass into acceleration. So acceleration is force by mass. Acceleration is force by mass. Okay. Which mass? 6 kg, 3 kg, or 1 kg? We want acceleration of the total system. So you should take mass of the total system. Total mass. Force is 20. 6 plus 3 plus 1 is 10. So 2 meter per second square is the acceleration of each block. Acceleration of each block, 2 meter per second square. Okay. Then force acting on each block. Force acting on each block. What should you do? I told you yesterday, if you want to study, if you want to understand how much force is acting on any one particular body or any one particular block, you should draw free body diagram of that block. Free body diagram of that block. So FBD of, first of all, I will draw for 1 kg. FBD of 1 kg block. This is 1 kg block, and show all the forces acting on 1 kg block. What are the forces acting on 1 kg block? If you look here, 20 Newton is pushing 6 kg block. 6 kg block is pushing 3 kg block. Okay. And 3 kg block is pushing 1 kg block. What are these forces? Normal reactions. I will call normal reaction by 6 kg on 3 kg as N, say, okay, N1. And normal reaction by 3 kg on 1 kg, I'll call it as N2. Okay. And from Newton's third law, it automatically means that if 6 kg is pushing 3 kg by a force N1, 3 kg will also be pushing 6 kg with the same force N1, but in opposite direction. And 3 kg is pushing 1 kg with normal reaction N2. So 1 kg will also be pushing 3 kg with normal reaction N2 in opposite direction. These are the different forces between the blocks. Now if I take 1 kg block, free body diagram of 1 kg block, what are the forces acting on 1 kg block? N2 is acting on 1 kg. Is N1 also is N1 also acting on 1 kg? No, N1 is acting only on 3 kg. On 1 kg only N2 is acting. And of course, these forces are, however, there. Its weight mg is downward, and this normal reaction due to the surface is upward. But I will not show this because they'll get cancelled and they don't contribute towards acceleration. That's why I'm not saying. Okay. Now, N2 is acting on 1 kg. So N2 is equal to 1 into 2. What is this? N2 is equal to ma. Mass is 1, acceleration is 2. So N2 is equal to 2 Newton. N2 is equal to 2 Newton. Okay. Then what about force on 3 kg block? Draw FBD of 3 kg. Free body diagram of 3 kg block. Three kg block. What are the forces acting? Force due to 6 kg N1 is acting like this. Okay. And at the same time, from this side, force due to 1 kg N2 is also acting. N2 is also acting. Due to the combined effect of these two forces N1 and N2, 3 kg block is getting accelerated in this direction. Okay. Now, if I apply Newton's second law, what is that Newton's second law? F net is equal to m. What is F net here? Why do you take n F net instead of F? Because
Because there are two forces acting.
if you find more than one force acting on the body, you should think of net force or resultant force. So N1 into 2 are acting. So the resultant force, what is it? Net force here, N1 minus N2 or N1 plus N2 or N2 minus N1 or N2 plus N1? How do you decide that? Is the resultant force N1 minus N2
N1 minus N2, sir, because N1 is more,
N1
sir.
plus N2 or N2 minus N1? What is the resultant force?
N1 minus N2, sir. N1 minus N2.
Why? Why?
Sir, because the magnitude of N1 is greater than N2, sir.
So N1 is has
How
more
can
force.
how can we say that?
Sir, because the force, the object, the 3 kg body is moving in the direction of force exerted by N1, sir.
Uh, Acceleration of 3 kg block is towards right. It is moving towards right. When can this happen? Only when N1 is greater than N2. Then only it will move towards right. If N1 and N2 are equal, it will not move. If N2 is greater than N1, it will move towards left. As the acceleration is towards right, that means 3 kg is moving towards right. That means N1 is greater than N2. If N1 is greater than N2, resultant force will be N1 minus N2. N1 minus N2. So N1 minus N2 is the net force, is equal to 3 into 2, which is equal to 6. We already have value of N2 here. So N1 minus 2 is equal to 6. That means N1 is equal to 8 Newton. N1 is equal to 8 Newton. N2 is 2 Newton, N1 is 8 Newton. Okay. This is the our value of N1. What about 6 kg block? FBD of 6 kg.
Sir, I think it is 12, sir.
Applied force 20 Newton is acting like this, and N1 is acting like this, and this is getting accelerated towards right. So F net equal to Ma. Net force is 20 minus N1 equal to 6 into 2, which is 12. And from here also you can check the value of N1. N1 is equal to 20 minus 12, which is equal to 8 Newton. Same as this.
Sir,
Hmm.
sir, here in the 3 kg block part, why
Oh.
did we take in the last N1 minus 2 is equal to 6, sir?
N2 is already 2 Newton.
Yes, sir. Okay.
Okay, so this is the answer. Okay, fine.
Sir,
Like this. Oh,
so for 6 kg, we don't need to calculate, sir, because the both the reactions are equal, sir.
which reactions are equal?
N1 and N1.
Only one N1 is acting on 6 kg due to 3 kg.
Yes, sir. The 3 kg N1 is also equals to the 6 kg N1, sir.
Yes, yes, that's what we have got here. That's what we have confirmed here.
Okay, sir.
Like this, you can get any number of blocks in contact with each other. You can find acceleration of the system and force acting on each block. Okay.
Sir,
Hmm.
sir, we are not here taking a normal reaction and weight of the object because both are equal. So that's why you're not taking it, right? In the
Both are
equation.
equal and opposite, and they are getting cancelled, and that's why the blocks are not moving in vertical direction. So we are not taking those forces.
Okay, sir.
But strictly speaking, you should show them also in FBD if you go as per the standard rule, standard procedure. Okay, next.
Sir, one can
Or
develop.
next situation is body is connected by strings. Body is connected by strings. Okay, what is this? Recall what we studied about tension. Whenever a string is loaded, tension is developed in the string, and this tension acts in two directions in the string. The direction of tension should be taken always away from the body of interest. Direction of tension is always away from the body of interest. Tension always acts along the string, and direction of tension,
Opposite to the force applied.
no, direction of tension is always away from the body of interest. Away from the body of interest. What do you mean by this? We will understand with examples. First situation, simple situation. This is a smooth horizontal surface. Smooth means target friction. This is a 4 kg block to which I am tying a string and pulling that string with a force of say 12 Newton. So due to the force that I am applying on the string, I am pulling the string. Tension is created in the string. In which direction? In both directions. Like this and like this. Now what do we want here? We want acceleration of the block. Same question in all situations. Find acceleration of the block. Okay. What is acceleration? This block will be getting accelerated in this direction. You are pulling the string. You are pulling the string. Who is pulling the block? String is pulling the block. How can string pull the block? By creating tension inside it. So what should be the direction of tension in that string? This or this? Towards left or towards right?
Towards right, sir.
Towards right. So direction of tension is this. Okay. So what is acceleration? Acceleration is force by mass.
The 3, sir.
So force here is nothing but tension, which is equal to applied force 12 by mass is 4. 3 meter per second square is acceleration. Okay. Fine. Next situation is this. Two kg block, 4 kg block. These two are connected by one string, and to 4 kg block, this is the another string attached, and a force of same 12 Newton is applied. Now question is, find tension in both strings, or before that, find number 1 acceleration of each block. Number 2 tension in both strings. Even these two things. Okay, right. First of all, thinking about acceleration of each block. If you are doing this thing practically, how will the two blocks move? With same acceleration or with different accelerations?
Same, sir.
Same acceleration. The two blocks will move with same acceleration. The two blocks move with same acceleration. Because what is the reason? Reason is the string that we are considering is inextensible. That means the string does not stretch. If the string does not stretch due to this 12 Newton applied force, this point of the string, let us say it is moving with some 2 meter per second square acceleration. This point should also move with 2 meter per second square because the string is not stretching. This distance, this length should be constant. This point is also moving with 2 meter per second square. This should also move with 2. This also with 2. This also with 2. This also with 2. So each and every point should move with same acceleration because the string is not stretching. If the string stretches, it's a different situation, which we don't study here. So the string is inextensible. All the blocks will move with same acceleration. Okay. What is that acceleration? Acceleration is force by mass. Which force? There is only one
Sir,
force.
2 meter per second only, sir.
Which mass you take, 2 kg or 4 kg or 6 kg?
6 kg, sir.
6 kg. So acceleration is 2 meter per second square.
Sir, we should take m total, na, sir?
If you find more than one body, you should take total mass. If you find more than one force, you should take net force. Thumb rule, remember. More than one body, total mass. More than one force, net force. Okay, acceleration is 2. Then tension in both strings. One point here. This is one string, this is the second string. Two are different strings. If nothing comes along the path of the string, tension will remain same throughout the string. Like this is one block of mass m. This is the string connected to that block. Tension in this string at this point, this point, this point, this point, this point, any point on the total entire string will be same. But if I connect another block m2 mass, and this is another string, tension here will be same, but tension here will be different than this value. These two tensions will be different. Why is it so? Because the reason is, let us say this tension is T1 in this string number 1. This tension is T2 in this string number 2. What is T1 doing? T1 is pulling both M2 and M1. T1 has to pull both M2 and M1. And what is the job of T2? T2 has to pull only M1. That's why their values will be different. So another thumb rule which you should remember. If you travel along a string, if you move along the length of the string, as long as nothing comes in your path, tension will not change. If any block, any other body, something comes in your path, tension will change. One string, one tension. Or in simple words, one string, one tension. One string, one tension. Another string, another tension. That's all. Okay, so here I'll call this tension as T1 and this tension as T2. Okay. To find T1, I want to find T1. To find T1, draw FBD of, on which block is T1 acting? On 2 kg or 4 kg?
On 4 kg, sir.
T1.
Sir, on 2 kg, sir.
T1 is actually acting on both 2 kg and 4 kg. How we will see? First of all, I will take, I want to find acceleration of 2 kg. I have already acceleration of 2 kg. Using that acceleration, I want to find tension T1. So I will take the FBD of 2 kg. What is the FBD of 2 kg? This is 2 kg block. What are the forces acting on it? mg and normal direction are there. They will get cancelled. I am not showing them. So the force which is responsible for pulling 2 kg block is T1. The force responsible for pulling 2 kg block is T1. Imagine this string is cut. Will 2 kg block move? No. That means this string is only responsible for pulling 2 kg. Okay. T1. Now if I write F equal to ma, what is F here? T1 is equal to mass is 2. Acceleration is also 2, which is equal to 4. So T1 is 4 Newton. Okay. Then what about T2? How to find T2? To find T2, draw free body diagram of 4 kg. This is 4 kg block. What are the forces acting on 4 kg block? T2 is pulling it towards right. At the same time, T1 is pulling it towards left. Yes or no? I told you tension will act in both directions along a string. 2 kg, 4 kg are connected by this string. The direction of tension in this string will be, if I take this point on the string, direction of tension on either side of these 2 points will this point will be this one and this one. Which direction should we take? We took the direction of T1 as this. Why? Because our body of interest was 2 kg mass. Our body of interest was 2 kg mass, and tension always acts away from the body of interest. So for 2 kg, direction of tension is this, away from 2 kg. But if you take 4 kg, now our body of interest is 4 kg. Then this tension cannot cause motion in 4 kg, right? Because you cannot push bodies by using a string. You can only
Sir,
pull.
the string is not pulling force, it is pulling 2 kg block.
You cannot push bodies using strings. You can only pull them. Imagine you tie a rope to a table and you are pulling that rope. You can move the table. Imagine you are pushing the rope. Will the table move? No. The string will get bent. It will slack and nothing happens. So tension in strings can only pull objects. It cannot push. This is like pushing 4 kg, which is not possible. It cannot push. Okay. So if your body of interest is object of interest is 4 kg, then direction of tension will be away from the body of interest, which is this. That's why I'm writing the direction of tension T1 as this on 4 kg block here. All this is, you need not know formulas, physics, all these things to do this. No, it's basic common sense. Okay, so the T1 is towards this left. Then 4 kg is getting accelerated in which direction? Towards right. To this situation, if I applied F net equal to ma, F net because there are two forces acting on 4 kg, T1, T2. Which is greater, which is smaller? Obviously, T2 is greater, T1 is smaller. So now what will be the net force? T2 minus T1 is equal to ma. M is 4 kg. Acceleration is 2, which is equal to 8. We have already got the value of T1, which is 4 Newton. That means T2 minus 4 is equal to 8. That means T2 is equal to 12 Newton. T2 is equal to 12 Newton, which is the same as applied force. Clear? Next. Two kg, 4 kg, 6 kg. Applied force is 24 Newton. And these are connected by strings like this 2 kg, 4 kg with one string, 4 kg, 6 kg with another string. Let us say tension in this string is T1, tension in this string is T2. Question is same question. Find acceleration of each block. Number 2, tensions T1 and T2. Again, all the 3 blocks will move with same acceleration, which is F by total mass. F is 24, total mass is 12, 2 meter per second square. Acceleration. T1 and T2. To find T1, I will draw FBD of 2 kg because T1 is acting on 2 kg. I will draw FBD of 2 kg mass. 2 kg block. What is the direction of tension? This is T1. What is its acceleration? A. In which direction? Towards right. So F is equal to ma. T1 is equal to 2 into 2. T1 is equal to 4 Newton. That's all. To find value of T2, you can do 2 things. You can either take 6 kg block or you can take 4 kg block. You can take any one. You will get the value of T2 because T2 is acting on both 4 kg and 6 kg. I will take 4 kg block. 4 kg block. What are the forces? Tension T2 towards right, tension T1 towards left, acceleration A towards right. So F net equal to ma. Net force T2 minus T1 because acceleration is towards right. Right side force should be greater, equal to ma. Ma is 4, acceleration is 2. T2 minus T1 we have already got here. 4 is equal to 8. That means T2 is equal to 12.
12, sir.
That's all. You get values of T1 and T2. And if you say that this is another third string, this tension is T3. This T3 will be equal to 24 Newton. So point is to find acceleration, you write force by total mass, and to find tension, you take any one body on which that tension is acting and draw FBD and apply F equal to ma. That's all. You will get tension. FBD, free body diagram, is a very, very important concept. You should have clarity what is FBD and how to draw FBD and how to apply Newton's second law to that FBD. F net equal to ma. Okay, another situation. Bodies connected by strings. Another situation. This is surface. A block of mass 4 kg is present, and you are tying a string to it like this, and you are applying 12 Newton force. What is the acceleration of block? What is the acceleration of block? You are pulling it up.
Sir, 0, sir.
You are pulling it up. You are lifting that block. You are tying a string to it. Acceleration is
Sir, it can also be 3 meter per second upwards, sir.
force by mass 12 by 4. 3 meter per second square, right?
Yes, sir.
Wrong.
Sir, no, sir. Again, 4 kgs weight will also be acting down.
That is the point here.
Sir, should you also do mg, sir?
See, in all the above questions until the previous question, we did not consider weight of the blocks because here also its weight 2g is acting. Here its weight 4g is acting. Here its weight 6g is acting. But all these weights, they were balanced by their normal reactions. They were balanced by normal reaction. That's why we did not consider them, because our motion was horizontal. Motion was horizontal. Here, motion of 4 kg block is vertical. If you try to pull 4 kg block, or if you try to lift 4 kg block, when can you lift a body? Only when the applied force by you is equal, at least equal to weight of the body. If the force that you are applying is less than weight of the body will not move at all. If the force is greater than the weight of the body, then only you can lift it. Okay. Or the boundary condition is applied force is equal to weight of the body. Then the body is ready to get lifted. So here, what is the weight of this 4 kg block?
40.
If you take G as 10, it is 40 Newton. Weight of 4 kg block is 40 Newton. If the force that you are applying is only 12 Newton, due to this 12 Newton, how can 40 Newton block be lifted? Not possible. So the
Zero,
block
sir.
will not move. Acceleration is 0. The block does not move. The block does not move. Okay. So point is, whenever you see motion in vertical direction, motion of bodies along vertical direction, you should not forget weight. You should not forget weight. Okay. Same 4 kg block. Hundred Newton force is applied. Acceleration of the block. Force by mass, or what to do? 100 Newton is acting upward. Its weight 4g is acting downward. So acceleration will be F net by mass. What is net force? 100 minus 4g by mass 4. 100 minus 4 into 10, 40 by 4.
So 15, sir.
60 by 4. 15 meter per second square will be the acceleration. This is how you should do it if the motion is along vertical direction. Next. Four kg, 6 kg connected by a string. This is another string to which 150 Newton force is applied. 150 Newton force is applied. Find acceleration of each block and let us say tension in this string is T. Tension T. Okay. How to do this? Simple, same procedure. Nothing new here. First of all, acceleration. Net force by total mass.
Sir, acceleration is 5, sir.
Let us see. What is the net force here? What is the net force here? 150 Newton in upward direction. Weight of this 6 kg, 6g in downward direction. Weight of this 4 kg, 4g in downward direction. So net force is 150 minus 6g minus 4g. 150 is trying to pull it up. 6g is trying to pull it down. 4g is trying to pull it down. So resultant force will be this 150 minus 6g minus 4g. by total mass 6 plus 4 10. How much?
14.2, sir.
150 minus 60 minus 40 by 10. 150 minus 100 by 10. 50 by 10. 5 meter per second square is the acceleration of each block. Next, tension T. To find tension T, I should draw free body diagram of what? 6 kg or 4 kg? Free body diagram of 6 kg or 4 kg to find tension T. You can draw for anyone. 4 kg is easier. 4 kg is easier. You can draw for 6 kg also. From that also you can get T. But 4 kg it is easier. So T is acting in this direction and acceleration of this block in upward direction. So if I write F net equal to MA, T in
Sir, I
upward
got T equals to 60, sir.
4 is 10 net force is T minus 4G is equal to 4 into 5. T minus 40 is equal to 20. That means T is equal to 60 Newton. T is equal to 60 Newton. This is the answer. Acceleration, tension. This is how you should solve questions when bodies are connected directly or through strings.
Sir, gravity is 10, sir. We have to multiply 4 with 10.
That's what I have done. I have multiplied by 4 on 10 only, no?
Yes, sir.
Again, you are saying gravity. I told it, I think not
Wait,
less
sir.
than. No. What did you call as
Acceleration due to
gravity?
gravity.
Acceleration. I told this, I think, not less than 10 times. Don't call G as gravity. G does not stand for gravity, is acceleration due to gravity. Calling it acceleration due to gravity might take 4 or 5 seconds extra time, but you should spend that time. There is a
Yes,
lot
sir.
of difference between gravity and acceleration due to gravity. Okay, if anyone is calling G as gravity, it might be due to 2 reasons. One reason is due to laziness. You don't want to pronounce it, call it it's so long name acceleration due to gravity. Second reason is ignorance. Both are not acceptable. Okay, bodies in contact. Other situations are there where you connect bodies with strings, and these strings run over pulleys. That's what we will discuss in our next class. Bodies, pulley block systems. Pulley block systems.
Sir, there the strings interact, sir.
Uh,
Okay, sir.
all right. So we'll continue in the next class.
Thank you, sir. Bye.